So, again, if you want to sit in front, you may do so. Alright, so we're going to start with the actual lectures for CS11. There's an attendance sheet being passed around, so kindly make sure that you are able to sign before the lecture ends today. Okay, so before anything else, again, as stated in lecture 0, attendance will only be counted once you open a ticket in the Discord server, and 2, once you answer the student info form. So make sure you do both of these things on or before Wednesday. So I did not put this in lecture 0, but just in case something happens to Discord or something, for backup, we'll also have Google Classroom. So this is the class code that you can use to join Google Classroom. We'll mainly be using this as a backup for important links and other announcements. So make sure you join these 3 platforms over here. Alright. So for lecture 1, we'll have first an overview of what programming is and why we have CS11 in the first place. While for lecture 2, we will start with the actual programming stuff. Okay, so let's talk about what computation is. Why does CS11 exist in the first place? Okay, when it comes to computer science, what does computer science actually mean? So computer science has 2 words, computer and science. So you might think that computer science is the study of computers. So what I'm using right now here, this is a computer. Is computer science the study of how this laptop I have here works? But aside from computer, there's also the word science. So when it comes to science, you've encountered a lot of sciences back in high school. One is math, of course. Or what other kinds of sciences do we use when it comes to computer science? Another thing you might be wondering is, if you didn't know, yung computer science department is under the College of Engineering, not science. So why is CS under M? So how is math, science, and engineering involved when it comes to computer science? In this first lecture, we'll mainly be going over why these 3 things are related and how they relate to computer science. Okay, so in order to know what computer science is, we need to know what computation is. So can anyone tell me what 67 times 69 is? Is this something you're capable of doing off mentally? Well, since we have a computer like this, we can just ask it. And apparently it's around 4,600. So this is probably the simplest kind of computation that you're familiar with. Basically, you're given some numbers, do something with them. So what else can you do with numbers? Aside from actually adding or multiplying them, you can also get information out of them. So if I give you, let's say, here I have let's say I have these 5 numbers. Nakikita naman. So if I have these 5 numbers, what's the second largest one among them? 12. So 15 is the largest, 12 is the second largest, and so on. So aside from actually computing stuff, we can also get information out of numbers. What other things can we ask? So, are you all aware of what a prime number is? So, just as a recap, a prime number is only divisible by 1 or itself. So, let's say you have the number 7. 7 is prime since it's divisible by 1, of course. It's also divisible by itself, but it's not divisible by any of these numbers in between. So the first few prime numbers are 2, 3, 5, 7, 11, and so on. So another form of computation is, aside from doing stuff with numbers or getting information, you can ask stuff about numbers. So is this really big number a prime number? So how big is this thing over here? Well, this is 2 raised to something minus 1. If we have something like 2 raised to 10 minus 1, that's around 1,000. 2 raised to 100 minus 1 is already pretty big. So as you can imagine, if we have 2 raised to 100 million, it's going to get pretty big. So kahit 1,000, it's already this many digits. So when you reach 2 to 100 million, it's going to take up quite a lot of digits. So you want to ask, is this entire thing a prime number? What do you think? Well, of course, the reason I'm asking this is it's this big number over here. We actually know that this is a prime number. So, in other words, out of all numbers from 1, 2, 3, and so on until this big number, minus 1, it's only divisible by itself or 1. And this was discovered last October 2024. So just over a year ago. So does anyone know what we call a prime number like this? So when we have 2 raised to some big thing, minus 1, we call that a Mersenne prime. So if I search that here, you'll see here, it's a prime number of the form 2 raised to something minus 1. So this is, I think, the largest Mersenne prime that we know of. So all of these are computations involving numbers. Of course, you're not restricted to numbers. As you'll see, when we say computation, we can also mean other kinds of stuff. So one is sending messages. So whatever messaging system you use, Messenger, Discord, Telegram, or whatever else, sending messages is also a form of computation. Okay, aside from all of these, what kinds of computations have you encountered so far? So if you think back to, say, high school, there are some examples of computations that you might have done. So for some of your science subjects, for example, you might have done a lot of measurements. So how long is something, how heavy is something, or how much time does something take. All of these measurements are a form of computation. What else? So as we've seen, we have mathematical operations on numbers. And aside from doing operations, we also get new information. So all of these are just examples of computation. So why do we have computation in the first place? Well, that's mainly because, well, we have our brains to think, but our brains can only do so much. So a while ago, when I asked you what 67 times 69 was, you couldn't answer immediately since these are relatively large numbers to multiply compared to 7 times 9. So computers are there to handle the more complicated stuff for us. Okay, so here I have some examples of tools that we've used throughout history in order to compute a bunch of stuff. So for the following, I want you to identify what they are, what kind of tool they are, and how they actually help us compute. So what is this thing shown on screen? What do you call this thing? This is a scale. So what does a scale do? A scale is used to compare different weights. So if you just have two random objects, let's say these two, you couldn't easily compare which one is heavier or not. So that's why we have scales like this, in order to compare the weights of different objects. How about this? What do we call this? Abacus. And what do we use it for? Usually, we use this for adding relatively small numbers. So you switch around yung beads here. You move them around in order to simulate some arithmetic computation.